Number 18, they give you a function, and all they want you to do is evaluate the function for 1. So they want you to replace x with 1. So if you put 1 in place of these x's, you're going to get 1 squared plus 1 over 1, which will simplify to a 2 over 1, which is just a 2. But if you plug a negative 2 in place, it's going to be a negative 2 squared plus 1 divided by a negative 2. And a negative 2 squared is a 4 plus 1 over a negative 2, which is a 5 over a negative 2. So 5 over negative 2 goes there, and 2 goes there. Number 19, they want to know when this function is positive. Let's do B and C first. When is it positive? When is it negative? And then let's see if we can find out what kind of function this is. So this function has 1, 2, 3 zeros. So I know it's going to be some type of a cubic, or the biggest exponent is going to be 3. Okay, the function is positive when it spits out positive answers. So if you have this function right here, y equals 2x, if we do a table for y equals 2x, 0 will spit out a 0, 1 will spit out a 2, 2 will spit out a 4, 3 will spit out a 6, a negative 1 will spit out a negative 2, a negative 2 will spit out a negative 4. So this function is negative when your outputs are negative. So right here, function is positive when your outputs are positive. So right here, that's when it's positive, that's when it's negative. So it's positive anytime your graph is above 0. So the red ones are when it's positive, and the blue parts of the graph are when it's negative, when it's below 0, when it's underneath 0. So let's do when it's negative. It is negative, and this line goes forever. So it's going to be negative all the way from negative infinity to 0. So anytime x is less than 0, that's when it's going to be negative. But now it's going to be negative sandwiched in between 3 and 5. So anytime x is bigger than 3 but smaller than 5, it is positive sandwiched between 0 and 3. Anytime x is bigger than 0 but smaller than 3, and then anytime x is greater than 5, it's going to be positive. Okay, now to come up with the polynomial, the hardest part is this, is finding the a, because that's kind of the number in front of the cube, because that's the slope, that's the dilation, and they're telling us it's just a 1, so we don't need to worry about that. So that's nice, because that is the hardest part. Now let's take these roots. These zeros are 0, 3, and 5. So if you take the zeros, you can work backwards and figure out what was the factor that gave you that 0. So 0 is going to turn into just an x. 3 is going to turn into a x minus 3, because if I plug a 3 in there, that's creating a 0. And 5 is going to turn into a x minus 5. Okay, now I'm going to do x minus 3 times x minus 5, and if I distribute that through, I know it's going to be x squared minus 8x plus 15. And then if I times that all by x, it's going to be x cubed minus 8x squared plus 15x. And this is the polynomial that will give me this graph. So x cubed minus 8x squared plus 15x equals y. Okay, 20 gives you kind of the same thing, looks like a cubic, and it wants to know what does it want to know? Show the x intervals when the function is increasing. So it's kind of like when it's positive and when it's negative. They want to know, when is it increasing? It is increasing when the slope is positive. So of all of these lines, there's kind of three lines. This part has a positive slope, and this part has a positive slope. So it's going to increase all the way up to infinity. So let's do this part right here. It looks like it starts to increase right here at 3. So on the number line, I'm going to come over here to 1, 2, 3, and I'm going to circle it. The question is, do I circle it and shade it in, or do I circle it and leave it empty? And I think we're going to circle it and leave it empty, because it's not really increasing at 3. It starts at 3 to increase. So 3 and anything to the right of 3. So 4, 5, 6, all the way to infinity, it's going to be increasing. So this is excluded. You're going to grab this excluded. You're not going to include the 3. Okay, this part, it's going to be increasing all the way to negative infinity, and it looks like it starts, when does it stop increasing? It stops increasing right here. It stops increasing at a -2. So on the number line, come over here at -2, circle it, and I think you leave it empty, because it's not increasing at -2. It stops to increase at -2, so it's going to be anything to the left of -2. So your graph, if you represent that on the number line, it should look like this. 21. Okay, this is an awesome question. The domain is restricted to the positive integers. So that is 1, 2, 3. There are no numbers in between. You cannot use 1.5. So you got 6 options here. Of the 6 options, which ones will make sense for the domain to be positive integers? The first one will not, because if you calculate the height of the ball at time, so here's time and here's the height. Time, the domain is the x, and time, there can be 1 second, there can be 2 seconds, but there's also an infinite number of points between 1 and 2 seconds. There's 1.3 seconds, 1.4, so this one's no good. Fahrenheit to Celsius, same thing. You're going to have Fahrenheit on the x-axis, and in between 20 degrees and 21 degrees Fahrenheit, there's 1,000,000 degrees. So that's not going to work. The cost of a bag of fruit based on its weight, same thing. If you've got the weight, there can be 1 pound, 2 pounds, but in between 1 and 2 pounds, there exists 1.4 pounds. And the domain says that cannot exist. It can only be integers. So this one's not going to make sense. Height in inches and returns the weight. So you give me the height. So there exists 70 inches, but between 70 and 71 inches, there's a handful of kids that are 70.2 inches. So this one's not going to make sense. So we got to the bottom 2. The bottom 2 are legit, and that is it. So the bottom 2, you got a function that calculates revenue based on the number of sales of a particular item. So let's say you're selling vacuums. You can sell 1 vacuum, and you can sell 2 vacuums, and you can sell 3 vacuums, but you cannot sell 1.5 vacuums. So that one makes sense. The cost of a field trip based on the number of kids. So this is the same. This is the number of kids. You can have 1 kid, 2 kids, 3 kids. You cannot have 3.4 kids. So that one works. Alright. John is at a store that sells pens for $2, pencils for $1. The equation shows the equation shown represents how many pens and pencils you can buy for 30 bucks. So A, you need to graph this. It's going to be easier to graph if you're graphing in y equals mx plus b. So solve for y. I'm going to minus 2x minus 2x. So you got y equals 30 minus 2x. Your b is going to be 30. That's your first dot. So you got a dot right here at 30. And then your m is a minus 2. So go down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And you just keep going and draw a line through all your dots. Okay, A is done. And then what about B? Place a number. So for every pen that John buys, the number of pencils he can buy. So here we go. We're gonna use either increases or decreases. So this dot right here, this dot at 30, this is 0 and 30. The X is actually my pens, and this is my pencil. So let me get another dot. This next dot is 1 pen and 28 pencils. The next dot is 2 pens and 26 pencils. So for every pen that he buys, the number of pencils is going to drop. It's going to decrease by 2. So if he were to buy 3 pens, he could only buy 24 pencils. So if you want more pens, that means less pencils. $23. Alright, they give you a function. They want you to give me what it is just by looking up the picture. Okay, so here's what we know. We know the vertex. We know 2 models. We know y equals ax squared plus bx plus c, and that looks like what they want here. And we know the vertex model, y equals ax minus h squared plus k. So I think the vertex is going to be easy to find. The vertex is at a -6, no, it's at over 2 and then down 16. That is my vertex. So if I plug this in for h and I plug this in for k, it's going to be x minus 2 squared minus 16. All I need to know is the a, and the a is the dilation. The dilation might be tougher to find. The dilation is the slope. So from this dot, my next dot, shoot. I don't think that's gonna work, because the next dot is right here, and from here to here I had to go up 4 and over 2, but I don't. That's not the dilation. It's not 4 over 2. The dilation is not. It's not going to be 2, because the dilation is. Oh shoot! I think we can only go. Oh, that's not. Yeah, they're counting by 2s. Maybe that will work. What we could do, and this is a smart thing to do, if we suppose that it's 2, if we think that it's 2, on the calculator, type this in. And if you type this into your calculator and graph it and turn the grid on, and if your vertex really is down here at 2 and -16, and it goes through this dot 6 and this dot -2, then you know you're 100% right. So you can kind of use the calculators, kind of use your street smarts to check and see if you're right. So I'm going to maybe pause and do that right now and see if we're close or see if we're off. Okay, so it's a good thing I did that because that's not right. This can't be 2. So I tried it with 2 and it does not cross at 5 and a -2. So it's not 2. And then just figured this out from my Excels. Your slope, the run, so the rise over the run always needs to be 1. So if you're doing the rise over the run, you don't go to the next dot, you just go wherever your run is 1. It's going to be like right here. So you're going to go up and over, and you're really going up 1 over 1. But how you can find that is, look, this A is what we're looking for, and this, it's the same thing in both forms. The A is going to be the number out in front very first, that's your dilation, and they're giving it to you. They don't want you to find that because that really is the hardest part to find. So your A is 1. So that's nice to know. We didn't even really have to hunt for it. So if I know my A is 1, then this is the formula right here. But they don't want the formula in transformation form. They want it in standard form. So in vertex form. So let's just clean it up. X minus 2 squared is x minus 2 times x minus 2. That's going to be x squared minus 4x plus 4 minus 16. So now these two are like terms, they can play together. So you got x squared minus 4x minus 12. So x squared minus 4x minus 12. Okay, they give you two functions. So 2 pieces. We're going to call it a piecewise function. Place one expression in each box to complete the equation for f of x. So you need to look when x is less than 1 or equal to 1. So on your x-axis right here is 1. So they want your eyeballs to be anywhere smaller than 1. So that's going to be this line right here. This line, so it's shaded and circled because it lands on 1, it includes 1, and anything smaller than 1. So this is a linear function. So I got 4 choices to match up with this linear function. And I know it's going to cross right here at -3. So the b is a -3. And this has a negative slope. So it's got to be this one. That's the only one with the negative slope and a b of -3. So that's this guy right here. Now the bottom one, they want you to look when is x greater than 1. So x is going to be greater than 1 anything this way. So you need to look at this line. And this line, it has a curve to it. So it's not going to be any of these linears. It's going to be either this guy or this guy. And again, you can use your calculator. Type this in, press enter, see if that matches this. Type this in, press enter. It's this one right here. This square root of x plus 2. So use your calculator, and then you can guarantee yourself you got it right. Okay, 25. We've never talked about, so you don't know. Arithmetic sequence and geometric sequence. They're pretty easy though. Arithmetic grows by addition. Arithmetic is G, because G grows by adding 3, adding 3, adding 3. Geometric is exponential. It grows by multiplication. So this is 3 to 6, that's times 2. 6 to 12 is times 2. 12 to 24 is times 2. So if it grows by multiplication, it's geometric. F is geometric. Grows by addition, it's arithmetic. Now, which one grows faster? Geometric grows way faster. F grows way faster than G. We're just doing these right now. Evaluate. This is a multiplication problem, so 3 times 2, that's going to be 6. 3 times a negative 7i is going to be a negative 21i. Plus 4i. Add your like terms. Negative 21 imaginaries and 4 imaginaries. That's going to be 6 reals and a negative 17 imaginaries. So 6 minus 17 imaginaries. 28. Solve it for x. They want x all by itself, so let's undo all these operations. Let's undo the minus, the plus 2. Minus 2 on both sides. So you got 2x squared equals minus 2. Undo the times by 2. Divide by 2, divide by 2. So you got x squared is equal to a negative 1. Undo the square, square root. So it's going to be plus or minus square root of a negative 1. And square root of a negative 1, that is I. So it's plus or minus imaginary. So plus 1 imaginary minus 1 imaginary. Okay, we've never talked about this either. But if you plug in positive exponents, that's multiplication. If you plug in negative exponents, that's division. So if you have like a 2 to the negative 4th, you can't have a negative exponent. So it's really, you're dividing by 2 to the 4th. But what happens when you plug in an exponent? If you plug in 4 to the 1/2, if you plug in exponents, it's a fraction. What really is going on is some type of a radical. And this is what you got to memorize. 4 to the 1/2 is equal to 4, the radical, the 2 is the index, and the 1 is the exponent. So 8 to the 1/3 is the same thing as the cube root of 8. So the square root, most of the time we never even put the 2. We just leave it off and it's implied that it's a 2. So it's implied that it's a square root. This is it. 1/2 as an exponent is the exact same thing as the square root. So the square root of 16, that's 4. So this needs to be 4 to the 1. Okay. The square root of 64 is 8. And 2 cubed is 8. So put a 2 here, put a 3 here. Okay, the 4th root of 27. Let's break up 27. See what is inside of 27. A 9 and a 3. And a 9 is a 3 and a 3. So they're really asking you to do the 4th root of 3 cubed. Now if you morph that to a exponent, the base is going to be 3. It's 3 to the 3/4. So 3 to the 3/4. And this is the same type of problem. Show all that are equal to 4 to the 3/2. If you've got an exponent and you raise it to another level, so 2 to the 1/3, you times them, times your tops, times your bottoms, that's going to be 2/3. That's not equal. Times them, 1/2 times 3 is going to be 3/2. That is equal. Morph this to a power, it's going to be 4 to the 2/3. It's not equal. This is the same thing. 4 to the 2/3. Not equal. 8. Not equal. 4 to the 3/2. This one is equal. Times them. That's going to be 4 to the 3/2. That is equal. This is going to be 4 to the 3/2. That is equal. And this is going to be 4 to the 2/3. That is not equal. So, there you go. That's it.